All right, moving on to 14.6 now, dealing with the y equals mx plus b form, which is called, what is the y equals mx plus b form called? This, we just named it. Y equals mx plus b. This right here, which my smart ink is not. What is it?
It's slope.
Intercept form. So I would remind yourself, I would write beside it, there's smart ink, slope intercept form. And we use CEPT when we talk about the y-intercept. It's CEPT. So we've got all these crazy lines over here, and we want to determine what's the slope and what's the y-intercept for each of them. Now, because I like you guys, I've given you a table where we can do this really easy. So we're using cards and we're going fast. Ella, my first equation up there. What's the slope? Rye.
Oh, I'm so sorry. I didn't mean
Fine,
to
do this one, Rye. What's the slope?
2.
What's the y-intercept?
The y-intercept is 1.
Thank you. Ella, the next one, what's my slope?
2.
And the y-intercept?
3.
Leah, my next one, what's my slope? It's on your paper if you can't see it. Negative 1/3. And y-intercept? Very good. Olivia, out of the room. Seth, my next one. What's my slope?
X.
What's in front of it? Yeah, the coefficient in front of it would be a 1. Write it in there if you need. What's the y-intercept? Is there a constant added on? So if there was, it would be a plus 0. So it's 0. Some of you might really benefit from writing in that plus 0. And Carrie, what about my last one? What's the slope there? What's the coefficient to x?
1.
Is there an x there?
No, sorry.
What's the coefficient?
0.
If there's no x there, 0. So my slope here is actually 0, except that 0 looked a little messy. So my slope is 0, which means it's what kind of line?
Unidentified.
Is it vertical or horizontal?
Horizontal.
Horizontal. Horizontal has no slope. Vertical has an infinite slope, which we cannot define. And my y-intercept then, Carrie, would be what? 1, yeah, because it's the constant value. So those last two are the ones that get people messed up. They're the ones that people struggle on. Nate, make sure you get this table filled in. It'll be up on the TV here in 2 seconds. So reminder, your m is your slope, your b is your y-intercept. This is called slope-intercept form. Yada, yada. You know this. So now we need to write an equation for each of these. Now, when determining the slope, this is something I think we could all benefit from, some extra practice. I like to start by placing a dot at my y-intercept and then finding the next point as I follow my line where it crosses an x and a y, like hash mark or whatever you want to call the light lines on the graph where it crosses and intersect on the grid. And then I really draw the lines, and this will help when we get to the distance formula, because we have to make right triangles to deal with the distance formula. And then I evaluate what's my rise, what's my run. So to get from this point to my next point, how many did I have to rise? 3. I went to 4, but I only went up 3. How many did I run?
1.
So when I think of that slope, it's the rise over the run, or just 3. The bigger the slope, the steeper the line, the quicker it goes up. So then, what was my y-intercept? 1. So my equation just becomes y equals 3x plus 1. Sorry, I didn't give you guys a lot of space. So Grace, when you look at the next one, what is your y-intercept? 4. So when I start, I'm going to place my dot there, and I know that my y-intercept is 4. Or I could just write like b is 4, because b we know represents the y-intercept. Then I find the next point where I cross, and I go my rise and my run. Now, Grace, when I think about my rise and run, what's my rise? What's my rise? Did I go up or down? Since I went down, -2. What's my run? So this just becomes -2. So my equation will be y equals -2x plus 4. Questions on this? My last one. Pranav, what's my y-intercept?
Is it -3?
Yep, my b is -3. What, to get to my next point, what's my rise and my run?
Is 1 and then 2.
So my m becomes 1 over 2. So my equation becomes what, Pranav?
Would it equal 1x?
Ooh, close.
1 over 2.
Yeah, 1/2 x.
Plus -3.
So instead of plus -3, we can just write, yep, -3. Try the got it on your own. First, identify your y-intercept. Then figure out your rise and run, making your slope, and then put it into slope-intercept form. Peyton, what's my y-intercept there? -2. What is my rise? -1 because I'm going down. What's my run? 3 because we're going right. So that makes my slope, my rise, over my run, which makes my equation -1/3 x minus 2. Any questions, comments, or concerns about writing in slope-intercept form? Yeah.
So you went down, right?
Well, yes.
Okay. So when the line is going down, do we count downwards? Like, do we count like you know how we draw the line like usually when we
Yeah.
go up like
The
that?
vertical and then the horizontal.
Yeah. So would we go? Cause I went up, and I got the answer wrong though.
So if you want to go the other way, like from this point to this point, then you went up 1 but left 3.
It's through simple.
So that would have been 1 over -3.
So
The rise to the,
right?
but this will still get -1/3 if you've done it right.
Because
I did it the other way. I did it right from the front.
Because when we go from my y-intercept to my other point, I went down and then I went right. So because I went down, it's -1. I go right, it's +3. -1 over +3.
I went from -2 down to 1, so I changed my fraction.
Have you found your mistake?
Yeah.
Okay, that's all I care about. Good job, guys. We're whizzing through this. So here's just some comparisons of when we have y equals mx compared to y equals mx plus b. What's the difference between those types of lines? We started the chapter by talking about only a certain type of relationship. No? Yeah. So these right here are proportional, whereas y equals mx plus b is not proportional. It's linear, but not proportional. And that also is given away right here. Shows a proportional relationship between x and y. So, is there a proportional relationship between Fahrenheit and Celsius?
yes. No.
Is 0 degrees Fahrenheit 0 degrees Celsius? No. So it cannot be proportional.
Close.
Is there a linear relationship?
Yes.
Yes, because the conversion can be written in an equation form. So we need to determine what equation for my line where x is my temperature in Celsius and y is my temperature in Fahrenheit. So what we're going to say, instead of y equals, we're going to say f equals, because f is my y. And instead of using x, we'll use c, because my x values are c. Now you could write it y equals and you could use x, but I'm just going to write it like this because it's an equation that we actually use. What is my y-intercept? Karen? 32. So my b here will be 32. And Rye, how do I figure out my slope?
Is it, are you going to use the, these 2 points right here? You go up,
See, this is where my change in y is not countable, but it's computable. 104 from 32. I started at a y of 32 and I went to a y of 104. Just do the subtraction.
Okay.
So we get 2 there, then 10 minus 3. So we get 72. So my rise is 72. My run, yeah, from x value to x value, 40. So I can also just compare the points, the y values of the points and the x values of the points. 72 and 40 actually both share a common factor of, what can I divide them both by?
8.
8. So if I divide these both by 8, I get 9 over 5. So my Fahrenheit temperature is 9/5. My Celsius plus 32.
Well, I mean, it said it on the other side.
No, because this, oh yeah, sorry. I thought it gave you the other temperature. Because the other conversion to go get the Celsius is 5/9 F minus 32, and that's in parentheses. So, all right, that's all we got today. Try the homework, and tomorrow we will finish up your test and just have some work time. I know, I love graphing. Linear equations explain a lot of real-world situations.